Hello, today I'll be showing you how to access the OVM Pro on our website, and I'm going to run through a quick application to get you guys going and show you how to use it. First off, you're going to go to Our Technologies up here at the top tab, and then right here you can see OVM Pro 3D Tool. Click on that, scroll down, and then go to OVM Pro 3D. Once you're in the OVM Pro, you'll be greeted with this page. You can either create a new system from scratch working on one of these four options here. We got sheet metal, plastic, glass display, and cardboard. Or you can work off of a predefined system. This is already set up with cups and pumps and whatnot. On example applications, you can see like the windshield of a car, for example, or the bumper of a car, cardboard boxes, sheet metal, and then you can work from there to customize it to your application. For this demo though, we're going to start from scratch and we're just going to go on a flat sheet metal plate, nice and simple. Okay, so we got our sheet metal plate here, and we've also got a regulator for the compressed air pressure. We're going to set this right away down to 45 since we're going to be working with PI cartridges, just so we don't forget later. All right, first up, we're going to set some pick points here, one in each of the corners. And all right, we're gonna make this a little bit bigger, or a bit compressed here. This is where you edit the object itself, the sheet metal. All right, we're gonna expand this out to 100 inches by 100 inches. And we'll go, let's see, 10 pounds. All right, drag these pick points out to the corners. Okay, and now we can add suction cups on each of these pick points. We'll go with 65 millimeters here, one on each. Okay, perfect. Now we can add our pump in for these cups. Throw this up top over here. We're going to go with a Pi Classic with one cartridge. This output's about 12.5 CFM, so that's plenty for just these four cups here. All right. And now to connect these up, we're going to add in some T connectors. Right. Got one between those cups there. We'll duplicate that. Rotate it around. We got one there. And then we'll put one in the middle from those two T connectors out to the pump. All right. Now you can just click Auto Connect all tubes and parts, and then we'll connect up the tubes between everything here. Okay. One thing you're going to want to do is, for most applications, you're going to have to expand that tubing size since it starts out pretty small. Yep, you can see here. This is where you find all the errors when you run the simulation. In the top right here, you'll see errors popping up with the yellow exclamation here. You can see it's saying the inner diameter is too small for a tubing and it wants us to expand that. So we'll go out, let's see, we'll go to 3/8 inch. And put that on all the tubes here. try rerunning that now. Okay. All right, so it's saying the feed pressure drop is 0 across the lines, which is a good thing actually. It's saying you can decrease the size of the tube a bit, but having 0 is optimal, so we don't need to really do anything with that error there. That's fine. Okay, and now that we've got this all set up, we can examine the graphs that we get from running the simulation. So you can see here, we get air consumption, pressure, lifting force. Then we also have the robot motion up there. The main ones we're going to be looking at are these bottom three though. Air consumption, you can see steady line when it's gripping and then drops down to 0 when it releases the product. Pressure, this is the vacuum pressure, so slowly decreases and then flattens out around its max and then drops back down to atmosphere to release the product. And then same sort of thing, but inverse with the lifting forces, increases as that vacuum pressure gets lower and lower, and then drops for releasing the product. One thing you can do with these pumps is you can add on the ES feature. That's the energy saving, and I'll show you in the graph here how that affects the pump. Each time you make a change as well, you're going to have to rerun that simulation to update the graphs. Okay, you can see here now the air consumption, it follows a straight line at first and then it drops down to 0. And that's because we build the vacuum pressure in this area here. And then once we reach our desired vacuum level, it cuts off that compressed air and locks in the vacuum pressure in the system. So you're not wasting compressed air throughout the gripping portion. That's very nice when you have long gripping periods to save on that compressed air cost. You can see here we're getting lots of savings even with a 10-second cycle time. You can edit this to whatever you want though. Say we want to make that a bit quicker, you can change that there. Double the speed. Rerun. You can see it's releasing around 2.7 seconds now, so a lot quicker than it was before. And then down here on the right, you also have your lifting forces, and you can customize your safety factor to what you need. For just vertical pick and places like this, you can normally just go with a 2x safety factor. But when you're working in shear or parallel, you're going to want to go with a 4x safety factor. And this should be a good starting point for you. You can save your system once you've made it up here. So once you come back into the system later, all your progress won't be lost. You'll be able to hop right back in where you last left off. And then another thing that's nice to note is down here you can go to summary and order. You can look at all those parts that you added into your system, get your part numbers right in here, and then you can bring that to us for ordering if you'd like to get a system. Lastly, if you want to share, you made this and wanted to share it, you can get the shareable link down here, send it direct to them or one of your colleagues, and then they can look at this system that you created and examine it as well. Thank you for hopping on board today.